Exercise 5D question number 1. Um, the bag contained 3 red and 5 blue beads. 3 red and 1, 2, 3, 4, 5. They are same size. So red 3 and blue 5. So probability of red is NR over number of red over total number, that is 3 over 8. Probability of B is S in B over NS, that is 5 over 8. So you can draw this one, red, blue, red, blue, red, blue. So this is 3 over 8, 5 over 8. This is 3 over 8, 5 over 8, 3 over 8, 5 over 8. So this is BB, this is BR, then this is RB, and this is R. Now the first question is we did, and the part B, find the probability that both beads are blue. Probability of both beads are blue. It means probability of B and B. It means probability of BA intersection B is PB times PB times 5 over 8 times 5 over 8, 25 over 64. So part C, find the probability that second bead is blue. Second bead is blue. Then probability of first bead B and B, or R and B. This one, so this is second, this is second. That means probability of B and B union R and B, which is probability of B and B plus probability of R and B. So B and B is PB times PB plus R and B is PR times PB. So this is, we already know this answer, 25 over 64, and PR times, so this is the root, R times B, 3 over 8, 5 over 8, 3 times 5, 15 over 64. Total answer, probability of R intersection B is PR times PB, that is 3 over 8 times 5 over 8, 15 over 64. So this is going to be 40 over 64. That is going to be 5 over 8. Question number 2. In a box, there are cards 1 to 9. Card is drawn at a random and not replaced. So this is without replacement. Um, card 1 to card 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many even cards? 1, 2, 3, 3, 4. Even 4 cards. Odd 5 cards. Uh, now there are uh, two drawn. The first one. So odd, even, odd, even, odd, even. So this is first taking. This is the second. First taking probability. P01 is N01 over NS. That is going to be 4 or 5 out of 9. And PE1 you will get like this, 4 out of 9. So this is 5 out of 9. This is 4 out of 9. Now if we pick up odd one, then the odd amount is going to be reduced. Then 4 over the total number is going to be 8. Now there are 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5. Odd and this is even, this is odd. So if you pick up odd card and not replace, then there are only 4 odd left. So then 4 and 4. Then odd is 4 out of 4, 4 out of 8, and even also 4 out of 8. But if we pick up even in this one, even, then 3 even and 5 odd. So then 5 out of 8, and this is 3 out of 8. Find part B. Find the probability that both cards are even. Both cards are even. So okay, probability are even. Probability of E1 and E2. So this is equal probability of E1 intersection E2. Equal probability, I will rewrite here again. Probability E1 intersection E2 equal probability of E1 multiply probability of E2 given E1. So this is going to be 4 over 9 times this is 3 over 8. So this is going to be 1 over 6. Part C, we need to find the probability that one card is odd and the other is even. So this is EE, this is EO, OE, and OO. Now those are the two occasions. One card is odd and the other is even. It means see. Probability of O1 E2. O1 intersection E2 union, other one is this one, E1 intersection O2. It means probability of O1 intersection E2 plus probability of E1 intersection O2. E1 intersection. This is this one. Probability of O1 multiplied by then this probability of E2 given O1 plus then this one probability of E1 then this one probability of O2 given E1. Then this is going to be 5 over 9 times 4 over 8 plus 4 over 9 times 5 over 8. It means this is 2 times 5 times 4 20, 4 times 5 20. It means 40 over 72. 5 over 9. Question number 3. Probability of Charlie take the bus is 0.4. Otherwise he walks, the probability is 0.6. And if we take the bus, he late with probability 0.2. So on time, late. So late 0.2, then 0.8 is on time. If he walks, then on time, late 0.4, then on time is 0.6. This is the key. B bus, W walk, on time, late. And the question is find the probability that Charlie is late to school. So this is the late. If we come by bus and late, and if we come by walk, this is the route he can late. Probability of late is probability of I'll write here probability of B intersection L union W intersection L. So this is B intersection L plus probability of W intersection L. Now then B intersection L, this one and this one. So that is probability of B multiplied by probability of late by bus. Late given B. Late given bus and probability of walk multiplied by probability of late given walk. So probability of B is 0.4. Probability of laid by bus is 0.2, 0.8 that one, and this is 0.6 times 0.4. This is going to be 24.0. This is going to be 0.08. So this is going to be 0.32. I think I have to correct this one. This is 0.3, and then this is 0.7. So this is 0.3, and this is going to be 18. Then 0.26. Question number 4. The Dixon play golf. The probability that score power under is 0.7. With the first hole 0.7 par or under. And it means 0.3 over par OP. And second, so if we manage to score power under on first, then the second hole is 0.8. So then par O under 0.8. So par over par is going to be 0.2. Addition is, then this is, if we fail, then it is 0.4 par O under. This is over par. So P O U par O under, and OP is over par. Draw the diagram to information. State whether the event score power under first hole. And so part B, they ask in the first power under and the second power under, those instances are independent or dependent. So they are not independent. It's clear. The events are not independent. And part C, find the probability that Mr. Dixon score power under on only one hole. So this is the root, and this is the root for this one. Probability of O under intersection with over par union probability of O, not probability, probability of POU intersection OP union probability OP intersection POU. So this value is probability of POU intersection OP plus probability of this one OP intersection POU. So then this is probability of POU times probability of OP given this one POU. This probability is OP given POU plus probability of OP multiply by this probability is POU given OP. Then 0.7 times 0.2 and 0.3 times 0.4. This is total is 0.26. Question number 5. It is a coin. It's not a fair coin. It is bias coin. Getting head is 1/3 and getting tail is 2/3. And the trial is 3 times head and tail, head and tail. And this is 1/3, this is 2/3, 1/3, 2/3. Now the first trial is not depend on the second trial is not depend on the first trial. There is no influence. But so yes, and this is head and tail, and the third one head and tail, head and tail, head and tail. So third trial also not depend on one or two. So 1/3, 2/3, 1/3, 2/3. Probability is still the same. 2/3, 1/3, 2/3. So this is a standard question, and find the that's done. Part B. Find the probability that the coin lands on head all 3 times. So all 3 times is this one. Probability of H, H, H. Mean probability of H intersection, H intersection, H. Then that is equal probability of H multiplied by probability of H multiplied by probability of H. You want 1, 2, 3, so you can put 1, 2, 3. So 1/3 times 1/3 times 1/3. So this is 1 over 27. Part C. Find the probability that the coin lands on heads only. Only one. So we can see that this is H, 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 T, H, T, H, H, T, 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 H, H, T, H, T, 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 H, and this is T, T, T. So once we can see once this one head, and this is also one head, and this is also one. So then probability of HTT union THT union TTH equal probability of H TT plus probability of THT plus probability of TTH. Then this is going to be probability of H times probability of T multiplied by probability of T, which is PH times probability of T square. Then P T P H P T. It means this is again PH times probability of PT square. Then this is P T P T and PH. Again this is PH times PT square. It means 3 times PH PT square. Then 3 times PH is 1/3. PT is 2/3. So this is 2/3 square. So this is going to be 4/9. So you can only do this one because they are independent. There is no given. So for example, this one, this probability is probability of H2 given H1, but that is equal to PH. So this probability is probability of this one, H3 given H2, that is also pH. This incident not depend on that one. But the previous one you can't put that square because they may change. So this is probability of getting head. 1/3 H2 given H1, but still equal to pH. Same, have the same power. This is H3 given H2, but still the same 1/3 because they are independent. Part D, find the probability. The whole experiment is repeated for a second trial. It's still the same setup. Find the probability of obtaining either 3 heads or 3 tails. Probability of getting 3 heads or 3 tails. So this is mean probability of H H H union T T T. O with union, usually O with union, N with intersection. Probability of H, okay, I'll write this one, equal, this is this line, probability of head times probability of head times probability of head plus, I had to write this, probability of H H H plus probability of T T T, then PH times PH times PH plus PT times PT times PT, this one and this one. So PH cube plus PT cube. So that is going to be 1/3 cube plus 2/3 cube. 1/27, 8/27, 9/27, 1/3. And question number 6. It is about tokens. 13 tokens. Blue 4, red 3, and yellow 7, yellow 6. So this is without replacement. So then without replacement, it has a conditional probability. Blue, red, yellow, 13 out, 4 out of 13, 3 out of 13, and 6 out of 13. Blue, red, yellow, blue, red, yellow, blue, red, yellow. Now, if you pick up blue, and this is the first taking, and this is the second taking. If you pick up blue first, then you are not going to replace it. Then there is three blues, and so this is the setup. Now blue 3 out of 10, 3 out of 12, red 3 out of 12, and yellow 6 out of 12. Go back to first one. If you pick up red, then you are not going to put it back. Then red become 2. Then blue 4 out of 10, 12, 10, 12, because all 12 here. Then red 2 out of 12, and yellow 6 out of 12. And go back to again normal first one. If you pick up yellow, then this is become 5. Now blue 4 out of 12, red 3 out of 12, and this is 5 out of 12. Now the first question is both tokens are yellow. So both tokens are yellow is this one. This is y1, y2. The probability of y1 and y2. It means probability of y1 and y2. So this is equal to probability of y1 multiplied by probability of y2 given y1 first taking. So this is y1 is 6 out of 13, y2 is 5 out of 12, so 30 out of 156, and that is going to be 5 out of 26. Part B, write down the probability that the third token is yellow given that the first two are yellows. First two are yellows and third one also yellow, y3. So this is b3, r3, y3. Now we have only 11 marbles, because when it's come to in this one there is only 12 marbles that are 4, 3 and 5. I'll go back to the normal this one. 4, 3 and 5. Then out of that, get in one more yellow. So we don't replace this one. This 5 become now 4. Now this is going to be 4 out of 11, 3 out of 11 and 4 out of 11. Now this is the probability, that probability of getting yellow 1, yellow, 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 1, 2, 3 is probability of y intersection y2 intersection y3 equal, actually we don't need to go that long, because they want what is the probability of third one getting yellow is probability of y3 getting, given that y2 is y2 y1 equal 4 over 11. I can write like this: y3 y2 y1 y2 given y2 y1, or simply you can write third y, third yellow. And for your knowledge, I like the probability of uh, y1 y2 y3. This is simple notation. It means probability of, sorry about this, so this is probability of y1 intersection y2 intersection y3. So then this is equal uh, y3 given y2, probability of y3 given y2, then probability of this one y3, then this one y2 given y1, probability of y2 given y1, and this one probability of y1. So this is 4 over 11, 5 over 12, and 6 over 13. There is no such a question, just for your information. I just jot down. And the last one is find the probability that all three tokens are different colors. So this is the second taking. And so B1, if it's going to this one, this is going to be red, same color. Then will be blue, red, and we have three. Out of that one, I'm just write one. B1, R2, and yellow, Y3. Other one is B1, Y2, and R3. This one R2, B2, then Y3 is missing. R2, R2 same color. R2, Y2, then what is the missing one? B3. Now here, so instead of writing three things, I am writing only one. Yellow, blue, and from here red. And this from here it is going to be yellow, red, and blue. Now here we pick blue and red, and yellow is still there, and 2 is missing. It means 6 out of 10, 6 out of 11. And here blue one is missing and yellow one is missing, but red one is not missing when you come in this direction. So the red one is still there as it is, that is 3 out of 11. Here red one is there, blue one is, red one and blue one is missing, yellow one is still there, 6 out of 11. And when it's come to here, red one is missing yellow, but blue is still there, so 3 out of 11. Now here 6, yellow is missing, blue is missing, but red is still there, so there 4 out of 2 missing, 11. And this is yellow missing, red missing, but still blue is there, then this is going to be 4 out of 11. Here 3 is 3, red is 3 out of 11. The blue is, red one is missing. Yeah, blue is 4 out of 11. Let me double check again. Yeah, blue is 4 out of 11, red is 3 out of 11, and Y3 is yellow is 6 out of 11. That's fine. Now we can see 4, 3, 6, 4, 6, 3, 3, 4, 6, 3, 6, 4. We'll see that pattern. 4, 3, 6. This is going to be 4, 6, 6. Which one is it? Yeah, 4, 3, 6, 4, 6, 3. How about this one? 3, 4, 6, 3, 6, 4. 3, 6, 4. This one. And this is 6, 4, 3. And this is 6, 3, 4. 6, 3, 4. So this is the numerator. So the denominator is going to be what? 13, 12, 11. Divide by 13, 12, 11. Divide by 13, 12, 11. 13, 12, 11. 13, 12, 11. And 13, 12, 11. And 13, 12, 11. 1, 2, 3, 4, 5, 6. 6 times 6 times 4 times 3 over 13, 12, 11. So answer is 36 over 140.